Hi friends, welcome to Elevate Training Solutions. In the last class we have seen how to calculate number of digits in a given number, right? As well as we have seen arithmetic progression and geometric progression also, right? Quadratic equations. In this class we are going to see how to calculate LCM, HCM, prime number, mean and median. So up to now you already gone through the method of prime number and everything. But in this class I am going to show you the new method how to calculate the prime number as well as HCM and LCM also. The simple method instead of wasting the time and also to reducing the time complexity. Okay. First see. If you observe here, we already in the last class we have gone through these three topics, right? And today class first we will see what is the mean and median. What is mean and median, and after that next prime number and followed by the LCM and HCM. Okay, we will see these methods, right? Yes, a mean and median. First you should know the definition. How we are going to calculate. Generally, mean means some of them may get confused. Please note this. It's very simple. It is the average of the given numbers. It is the average of the given numbers. Simply, it is the average of the given number. For example, they'll give us some numbers and find the mean of the given number. Given numbers. You simply add all the numbers. Add all the numbers and sum of all numbers by n, then you will get this the average of the mean of the given numbers. It's very simple, right? Coming to the median. Median is the middle value of the set of data. What is the middle value? For example, if you consider that 2, 9, 6, 4, 8 is the 11, right? If you consider these, what is the median of these values? If these two are the median value, not right like that. Please note this median. If you are going to calculate the median, first the data should be in the ascending order. The data should be in the ascending order. See, first you just make this data in ascending order. First 2 and 2 followed by what is the smallest value next? 4, right? And 4 followed by 6, right? 6 followed by 8, right? 8 followed by 9, right? 9 by 11. After that, you just find it's a even series or odd series. Means the length of the series is even or odd. If it is a odd, simply you can make that n plus 1 by 2. That is the digit. Means if you consider here, see. So this is it is a even, right? So for this reason, first we can find that, so middle of the two values, find the middle of the two values and find the average. This is the median of the given numbers. For example, if you consider 1, 2, 3, 4, 5. Now series is odd, right? You simply take the middle value as your median. For example, it is odd. You can pick the two numbers, middle of the two numbers, right? Middle of the two numbers, and you can find the average of the two numbers, and that is the median of the given series. This is the difference between the mean and median. Please note these 2 points. Okay, this is just definition, but if they ask the question, write a program to find the median of the given series of numbers, or find the what is the mean of the given numbers, they may ask the question, but they didn't mention the definition. You need to find the definition, right? For that reason I just mentioned here, right? How to calculate the median of the odd series and how to calculate the median of the even series. That is the only difference. Mean is just very common. You just find the sum of all the numbers and you can divide with the n value. Then you will get the what is the average of the given numbers, right? and prime numbers. You know very well. Prime is a number is divisible by it and itself is called as a prime number. Right? We know very well. Let us see. First, I want to show a small code how to calculate the mean of the prime number of a given. Check the number is prime or not. Prime or not. For example, n is the input, right? N is the input. I'm going to explain the through program only. N, right? So here I need to find that what is the prime number of the given number. Prime. So up to I need to calculate from, for example, if I equal to 2, generally what are you going to do? I equal to 1, directly I am going to the better method. Instead of doing all the things, simply just find the factors, right? While I is less than n, right? I is less than n. Okay, if n is modular division of I is equal to 0 at any point of the moment, you just return false, right? Otherwise you just return true. Okay, after that every time you need to increase the value, right? I equal to I plus 1. Then what happened? See, print prime of 5. What is the output? It's true, right? 5 is the prime number. For example, if you consider 1, it's false, right? For example, if you consider here the value is this much big, right? So but if you write this code, in normal method, the loop repeats this many times. But what I did here, I simply reduce when the first time it divisible, I'm simply going to stop the process. Right? Please note this. And better than this method is I into I. Even please don't use the square root. Generally, everybody is saying that the square root. Okay? Don't use the square root. Instead of use square root, you just use the I square. Because square root takes us some more time to calculate. That is the reason. Right? Even this one also will give the correct result. So we don't know the big digits, right? So we'll check with the small digits. It's false, right? And if you take the 23, let us check. It's true, right? What it is going to do here, sir, why you used I square? So instead of I, why sir, why? What is the need for use the I square means? See, what I am going to check here, please note this. What I am going to check here, see. So already I took the 2, right? So 2 square. So 2 square means the 4. For example, even for 4, if you consider 4 also, it will work. For the edge test cases, see. For example, here I am going to apply 4. See what happened. False, right? It is not prime number, right? So what I am going to do here, instead of checking all the numbers, because if you take 100, see 100, what is the square root of 100? 10 only, right? 10 means if you check the factors from 1 to 10, it's enough. After the 10, what happened? For example, 100 factors are 1, 2, 3, no, right? 4 after 4, 5, yes. 6, no, right? 7, no, right? 8 is the possible for the 100? No, right? 10, right? After 10, again we'll get the 10 only. So 10 is the reverse order. So 5 means 20, 25, and 2 means 50 and 100. So means the reverse order, it will get the reverse. That is the reason if you find the square root means square root, it's enough to find out. It is enough to calculate the prime number. That is the reason. So, but most of them use SQRT, SQRT of n. Instead of using SQRT, you just use I square. So both are same, right? Both are same. So what you are going to write? SQRT of n, right? Instead of that, what I am going to do? I'm sending this one in this side. So simply this value goes to I square less than or equal to n. Both are same. I just use a small mathematical function here. So this is the best method to find the prime number of a given number is prime or not. But some of them may ask the question, print the prime numbers between 1 to n. 1 to n. So how to calculate the prime numbers between 1 to n? Is there any method? I'm going to teach you the same thing. See, here I want to print the prime numbers between 1 to 50. 1 is not a prime number, you leave it there. So 2. I'm simply going to take one thing. First, I can consider the first prime number. Okay. After this prime number, what I'm going to do, I can do the numbers which are divisible by 2. I can make it as a false. Initially, I take the one false list, right? From that point, I'm going to take all the 2 counts. So all the 2 counts I'm going to cancel, right? So 12, 14, all even numbers. Simply it's called as all even numbers. Sorry, not this one, right? So 20, right? 22, 24, 26, 28, 30, and 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, right? After that, I'm going to put the next prime number. So 3 is not a strike off, right? I'm simply take the 3. So 3 has prime number, yes. So then I can strike. And 3 divisibles. 3, 2 just 6. So 3 plus 3, 6. 6 plus 3, 9, strike off. 9 plus 3, 12, 15, strike off. And 15, 18, already striked off. So 21, 24, striked off. 27, strike off. 26. So after the 27, 30, striked off. 33, 36, striked off. 39, 42, 45, strike off. 45, after 45, what is the value is there? 48, striked off. Stop the process. After that 4 is striked off, right? Just leave the number. No need to consider. Okay, next comes to here. 5 is the prime number, right? 5 is the prime. After that 5 multiples. 5 plus 5, 10. 10 plus 5, 15. 15 plus 20. 20 plus 25, strike off. 30, strike off. 35, strike off. 40, strike off. 45, strike off. 50, strike off. Right? After that 7. Again 7 multiples. 7 is the prime, right? So like that we need to find. Sir, how we are going to implement this one? I will show you. No need to worry. See, already we find the given number is prime or not, right? After that, what I am going to do, I am going to take. So I don't know what is the n value. So n value is 50, right? N value is 50. So I want to find all the prime numbers between 1 to 50. I mean 2 to 50, right? First, I can take the one binary number, one binary value. So here, what I'm going to do, L equal to, so initially all are true. Sorry, TREV, right? True into n plus 1 means, so generally the list starts with 0, right? 0 to 49, but I need to make the 50 also. Simply I make a 150 list. All are true initially. I assume that all are prime numbers. Right? All are prime numbers. So after that, what I am going to do here? Here please note this. Why I need to waste the time with the even numbers? We know already. We know already 2 is the prime number. 2 is the prime number. So instead of wasting the time, time, so what I'm going to do, for I in, sorry, otherwise you can take the while loop. So because easy to control, right? I is less than or equal to n, right? Less than or equal to n, because we need to print, right? We need to print. That is the reason I took here. But instead of that, you can take I square here also, it will work. I square, you can take I square, that will work also, it will here, that will work, right? After that, what I'm going to do, I'm going to take one by one value. But see, my I value starts with 3. My I value starts with 3, right? 3, I'm going to take only even numbers, sorry, odd numbers, 3, 5, 7, like that. Even part also I reduced. I made a algorithm like this here. Here, what I'm going to do, check the I is prime or not. First, if prime is the function already I wrote, right? Prime is the function I wrote, right? If it is a prime, if it is the prime, what I need to check? So if it is a prime, before that, if it is not, and also what I need to check? If and L of I, L of 3, L of 3 is already, what is there in the L of 3? L of 3 is a true, right? It is already true, right? So true and prime, so both are true, then only enter into the condition. Here what you need to do, all the numbers which starts with, which starts with 3 multiples, you make it false. Simply you just make it false. And as well as you just print first, print of I, means I just have printed my I value, the prime number value. And after that, what I am going to do here, listen carefully, what I am going to do here, j equal to I plus, so what is that? I plus, yeah, I plus I, then the value is goes to double, right? The value is goes to double. And from there, so I just use a one more while loop, while j value is less than or equal to n, until I reach to the j value, until I reach to the n value. What I need to do, L of j equal to false. I just make it false. Let's see, false, right? After that, j value is goes to increment, 6 is over, right? 6, after the 6 it goes to, what is the value it needs to go? 9, 12, like that, right? You simply make it the I, instead of plus 1 plus 2, you just use I. I means I, what is the value is there in the I? 3, right? So that is why I mentioned I. After that, simply what I'm going to do here, please note this, I value is goes to increment by 2. So 3, 5. So by default, the value is goes to reduced. Let us see what happened if you run this program. Yes, I did mistake somewhere. We need to check it. So 3, right? So after the 3, yeah, where I did the mistake? I value is I less than or equal to n, right? And yeah, so this should be incremented here, not there here, right? See, these are the prime numbers. Is this clear? Is this clear? So simply, so even if you take, if you consider, see here, if you consider 50,000. See, give the very little time complexity. If you consider in the normal method, if you consider the normal method, how much time it takes to find out the prime numbers up to these numbers. It's a printing time. That is why it took much time. Otherwise, it doesn't take the much time. All the prime numbers needs to print. I have given the 50,000, right? Is this clear? Only what I did here, I just take this value as true. If the value is already false, if you make the value as false, so it doesn't go for the even prime number. It doesn't go for the prime number checking. It stopped here only. It stopped here only. But in the normal method, what you need to check? Every time check 4, 5, 6, 7, 8, 9, 10, 11, 15, 14, like that. But here, if you check the 4, after that, all four multiples are make it as a even 4, it doesn't enter into the 4 because all even numbers already are removed from this process. All even numbers are removed from this process. Okay, so for that reason we just went the 2 also. Is this clear? Okay, so this is the way to find the prime numbers. This is the best method to find the prime numbers, right? This method is called as a sieve of Erthos. Yes, it's a method called this is a name, right? And after that, LCM and HCF. You know, this is the formula for LCM and HCF. If you know HCM, if you know LCM, okay, you just find the A into B, then you can find the vice versa. Please note that. Instead of finding LCM, so my suggestion is, if your question is finding the LCM of the given numbers, how you need to solve, right? So instead of that, please note this, find the GCD of given two numbers. That is a better. Don't solve the LCM based, because least common multiplier, it needs to find all the factors and it needs to take the common factors and you need to multiply, right? Instead of that, you just find the GCD. I'll tell you the reason, and also first we'll discuss the GCD of given two numbers. Generally, you can even GCD also, you just find all the factors, right? You just leave that method. Don't use that method. Instead of that, you just use this method. What is the method is, please note this. For example, A equal to 15 and B equal to here the value is 16, here the value is 6. Okay, you need to find the GCD of these two numbers. Generally, if you want to find the GCD of these two numbers, please note this is the method we are going to use. 16, 6, 16 1 no, 16 0, right? So 0, 6, and this 16 comes to here. 16 2 12, right? 4, right? Next, this 6 2 comes to here. 6 4 1 4, 2, 4, right? 2 2 4, 0 means you need to repeat this process until you get the 0. Until you will get the 0. So this is the GCD of these two numbers. 2 is the GCD of these two numbers. How to develop the algorithm? See, simply you can write an algorithm, that is A modulo division B is not equal to 0. You need to repeat the process. You need to repeat the process. If it is not, what you need to do? You have to swap the process. You need to swap the process. For that purpose, see, this value is right, 16 is there. So A value and B, right? You simply take that B value, T equal to B. After that, so B equal to what B becomes the modular division of these two numbers, right? B becomes the modular division of these two numbers. So just do the same thing. After that, so here 16 comes to A, right? And so B comes to A, right? So B is, where is the B? T, right? So simply A equal to B. That's all. That's all. Let us implement what is the algorithm. I hope it is clear, right? And here you have two values, right? A equal to 6 and B equal to 16. You need to find the GCD of these two numbers. What I said, you just write a while loop. Just write a while loop, and so A modulo division B is not equal to 0. You need to repeat the process until not equal to 0. After that, what I said, you just store the temporary value B value, and after that, so the remainder of the two numbers comes to B, right? So A modulo division B. After that, yes. So T. That's all. Result is stored at, where is the result? B only, right? That's all. This much simple. This much simple. For example, if you want LCM of the two numbers, simple. You know already GCD, right? You simply make that. So A into B. 4 is the value. LCM of the two numbers. A into, sorry, the values may be changed, right? A1 equal to, sorry, B1 equal to, because the values A1, B1, sorry, 48. 48 is the LCM of the two numbers. From our formula, see, what is the formula? Now you know HCF, right? You know HCF. You just J LCM equal to A into B by HCF. Please remember this formula and remember this procedure. Then you know how to find the GCD of given two numbers. Up to now, it is okay. But sir, what happened if A, B, C and 1 minute? I'll tell you. Most of them ask the question, sir, if somebody, if if C is also there, C is 8. So what is the GCD of these three numbers? How to calculate? What is the process? So for that purpose, you simply made this one as in the function def of GCD of A comma B, right? So after that, you just return B, right? Return B. I just put inside the function, that's all. I didn't do anything. Here, instead of pausing this one, what I'm going to do, GCD of A comma B. See, if you run this code, yeah, I forgot the bracket, right? GCD is 2, right? Now I'm getting. So if you want, find the, see, for example, sir, I have one more value, C equal to 7. What is the GCD? So after finding this GCD, you just write a one more GCD. Sorry, GCD of C, comma, GCD of A comma B. One. Is this clear? Okay. So if you find GCD of more than 2, this is the process. You may have one more doubt, sir. For example, if they ask the LCM of these three numbers, LCM of these three numbers. Otherwise, LCM of list of numbers. LCM of list of numbers. How to solve that problem? LCM of list of numbers. How to solve that problem? See, same, but don't multiply A into B into C like this. This is the wrong way. Please note this. First, you need to find this LCM of A into B. After that, you can go for the C only. So, how mean? See, for example, 2, 3, 4. Three numbers are there. Three numbers are there. First, GCD of these two numbers. What is the GCD of these two numbers? I am going to show you the mathematical form. GCD of 2 into 3. So, we will get 1, right? So, GCD is 1, right? And so, LCM of these two numbers. LCM of these two numbers. So, means 2 into 3. 6 by GCD 1. So, 6 is the LCM of these two numbers. After that, what is the means? These 2 is over. Next, you can take the 4. 4. What is the GCD of 6 and 4? What is the GCD of 6 and 4? 2, right? 2, right? So, 2 is the answer. GCD is 2, right? After that, what you need to do? Now, you require LCM, final LCM, right? So, 6 into 4, 24, right? 24 by 2, 12. So, 12 is the LCM of these three numbers. Right? Is this clear? Is this clear? Now we can write one more function LCM. That is your task. Okay? If you are not unable to solve, you just ask me in the comment box. Definitely I will help you for the code. Okay? That is your task. Please solve. So GC. Now in this class you learned how to find the prime numbers and how to find the LCM and GCD. Don't try to solve the LCM. LCM solve you can through the GCD process. It reduces the time complexity. So how much it reduced means, see, it takes that log of min of A comma B. That is the time complexity. That is the reason. Right? Thank you very much. So I'm requesting you, please share my channel details with your friends. Okay? So I'm just doing this for my passion, that's all. So nothing for money. Okay, please share, please, I'm very requesting, please share my channel details with your friends and suggest, and please like and comment on my video. It is very helpful. Okay, thank you very much. Hi friends, please subscribe my channel for technical training and placement related videos, and if you want more updates on my videos, please click on bell icon. Thank you for subscribing.